All right, we're in the Helicopter Flying Handbook, Chapter 13, Night Operations. This would be page 2 to 3, Visions in Flight. The visual sense is especially important in collision avoidance and depth perception. A pilot's vision sensors are the eyes. Even though they are not perfect in the way they function, due to the structure of the human eye, illusions and blind spots occur. The more pilots understand the eye and how it functions, the easier it is to compensate for these illusions and blind spots. Figure 13-3 shows the basic anatomy of the human eye and how it is like a camera. A camera is able to focus on near and far objects by changing the distance between the lens and the film. Objects can be seen clearly at various distances because the shape of the eye lens is changed automatically by small muscles. All right, so figure 13-2, example of the view that might be experienced by someone with astigmatism. Normal view. Can't see any power lines way down there. Yep. Okay, and then we got the eye, the human eye. The rods and cones film of the retina and the receptors which record the image and transmit it through the optic nerve to the brain for interpretation. The rods. The pupil aperture is the opening and center of the iris. The size of the pupil is adjusted to control the amount of light entering the eye. The cornea, light passes through the cornea, the transparent window of the front of the eye, and then through the lens to focus on the retina. All right, so visual acuity. Normal visual acuity or sharpness is 20/20. A value of 20/80 indicates that an individual reads at 20 feet the letters that an individual with normal acuity 20/20 reads at 80 feet away. The human eye functions like a camera. It has an instantaneous field of view, which is oval and typically measures 120 degrees vertically by 150 degrees horizontally. When both eyes are used for viewing, the overall field of vision measures about 120 degrees vertically by 200 degrees horizontally. All right, this is page 4 of 10. The eye automatically adjusts for the light level experienced. During night flight, the cockpit and instrument lights should be as dim as possible. The eye can then adjust for the outside lighting conditions, ambient lighting to see outside. The dimmer the inside lighting, the better you can see outside. So the eye, vision is primarily the result of light striking photosensitive layer called the retina at the back of the eye. The retina is composed of light-sensitive cones and rods. The cones in the eye perceive an image best when the light is bright, while the rods work best in low light. The pattern of light that strikes the cones and rods is transmitted as electrical pulses by the optic nerve to the brain, where the signals are interpreted as an image. Cones. Cones are concentrated around the center of the retina. They gradually diminish in number as the distance from the center increases. Cones allow color perception by sensing red, blue, and green light. Directly behind the lens of the retina is the small notched area called the fovea. This area contains only a high concentration of cone receptors. The best vision in daylight is obtained by looking directly at the object. This focuses the image on the fovea, where detail is best seen. The cone, however, do not function well in darkness, which explains why color is not seen as vividly at night as it is during the day. Rods. Concentrated outside the fovea, the rods are the dim light and night receptors. The number of rods increases as the distance from the fovea increases. Rods sense images only in black and white because the rods are not located directly behind the pupil. They're responsible for most peripheral vision. Images that move are perceived more easily by the rods area than by the cones in the fovea. If you have ever seen something move out of the corner of your eye, it was most likely detected by rod receptors. In low light, the cone lose much of their function, while rods become more receptive. The eye sacrifices sharpness for sensitivity. The ability to see an object directly in front of you is reduced, and much depth perception is lost, as well as judgment of size. The concentration of cones in the fovea can make a night blind spot at the center of vision. How well a person sees at night is determined by the rods in the eyes, as well as the amount of light allowed into the eyes. The wider the pupil is open at night, the better night vision becomes. All right, so we'll hold off there. That's holding off on page 4 of 10. That was your visual acuity. Vision in flight, visual acuity, the eye, cones, rods. All right, cool. Page 4 of 10, chapter 13.